So in y equals, clear if you have anything, or I don't have anything because they reset everything. So let's graph this one, -2, parentheses, x plus 1. If you need any help with the graphing calculator, let me know. And then plus 8. Let me know when you have this figured out. X is right next to alpha. It's that button that says X, T, theta, N. Okay? So now let's click on zoom. I am going to use the standard viewing window, but I want you to remember what the standard viewing window means. It means this: positive 10, negative 10, positive 10, negative 10. Will this graph fit in that? Yes, because it has -1, 8. So I'll click on zoom and then use standard 6. Standard is 6. That's exactly what we just talked about. And then press enter. And you will see the graph. It's coming. Oh, it's frozen again. So it's not coming. But your graph should be okay. It should cross at -3. It should go up till -1, 8. And it should come back down, cross again the x-axis at 1, 0. Okay. I want to stop this. I don't need it, but we may need it later. Maybe I should just turn it off, but it's not going to do it, though. So, what am I looking for? Devices. No, I'm looking for. We're looking for control panel. No, I don't see it. Should be some question. I just wanted to stop it because it's. No, I don't want to waste my time with that. Okay, very good. If we need it, we're going to use the calculator, and I'll come over and help you with the calculator because it's not working. Okay, very good. On page 708, I'd like to touch up on each and every item that you will see on the test. So, for example, do we want to go back to solving by factoring? Or are we okay with that? Okay. Square root property. Are we okay with that? Yes? Okay. Completing the square. I think we should look at an example with completing the square. Okay. So let's say problem 5 on page 708. I recommend all those problems in the review. There are only 2 pages. They all have the answer in the back. I would review those. Okay. Now, we can also do this. If you would like to take the test next Wednesday, we can meet on Tuesday from 4 and review again. It's up to you. You let me know. Okay. So we have x squared plus 3x plus 1 equals 0. Okay. We're asked to solve this equation by completing the square. There are 4 steps in completing the square. Step number 1, identify the middle coefficient, which is 3. Step number 2, I have to divide this number by 2. Step number 3, I have to square this number, and I get 9/4. And step number 4, I have to add 9/4 to both sides. It is mandatory to be on both sides. Otherwise, I change the problem. So I will rewrite the equation. as x squared plus 3x plus 9 over 4. I will definitely move 1 equals 9 over 4 minus 1. So the middle coefficient is 3. I divide 3 by 2. I square 3 halves. I get 9/4. And 9/4 is the quantity that I have to add to both sides. Good. Now I know what this is. How do I know? Because I made it so. So these 3 terms will be replaced by exactly what I squared to get 9/4, of course. Now the right hand side, I have to find the least common denominator. And I have to change 1 into 4 over 4. So the numerator becomes perfect. Now, after all this effort, I can solve. But I have another method that allows me to finish it up, or helps me finish it up. And the method is called? Right. So I take the square root from both sides. The left-hand side should be the absolute value of x plus 3 halves. But that's okay because I know what to do instead of that. Plus or minus the square root of 5 over 2. I'm allowed to split the radical if the radicand is a quotient. So it will be the square root of 5 over the square root of 4. And the square root of 4 is 2. Now one more step. I have to move 3 halves right here, right behind the equal symbol with the opposite sign. And that is it. If the discriminant of a quadratic equation has the given value, and the value will be given to us, determine the number and type of solutions of the quadratic equation. So if the discriminant equals -8, or if it is 0, or if it is 48. So what are the options? So when the discriminant is -8, how many solutions and what type will the equation have? Very good. 2 imaginary solutions. 0. 1 real. We know it's a double, but we know 1 real solution. And when the discriminant is 48, 2 different or distinct real solutions. Perfect. Do we want to practice a quadratic formula again? We're going to have it in word problems. So do we need to practice another one with the quadratic formula?
In a word problem?
Yeah.
Can we do that?
Yeah. So let's look at problem 19. 19 on page 708. Cadets graduating from military school usually toss their hats high into the air at the end of the ceremony. One cadet threw his hat so that the distance, d of t, in feet above ground, t seconds after it was thrown, so d of t is the distance above ground, t time in seconds, and the function is given as d of t equals -16t squared plus 30t plus 6. Okay. Question A, part A. Find the distance above the ground of the hat 1 second after it was thrown in the air. Find the distance that the hat reached a second after he or she threw it up in the air. What am I asked to do and how do I do it? Yes?
So would it be D of 1?
Of course. D of 1, which is negative 16 plus 30 plus 6. Very good. 30 plus 6 is 36. 36 minus 16 is measurement unit. Please remember measurement unit. Feet. Part B. Find the time it takes the hat to hit the ground. Give an exact time and a 1 decimal place approximation. Say it again.
They need to replace
Yes?
distance with 0.
Exactly. Exactly. So 0 equals negative 16t squared plus 30t plus 6. Exactly. It's quadratic. I don't like it on this side because it has a negative leading coefficient, so I'm going to move everything to the other side. Did I get it?
I didn't even see.
It's been here for 3 days. Annoying me for 3 days. Unbelievable. It has it has guts for sure. Okay, 16t squared minus 30t. Maybe it doesn't come back now. Good. So I moved everything to the other side because I refuse to solve a quadratic equation with a what? Leading coefficient. Yes, you can always multiply by negative 1. Good. So what should I do first before I even think of the quadratic formula? Divide both sides and simplify it by the greatest common factor, which is? They're all even numbers, right? So this is 8t squared minus 15t minus 3 equals 0. Easier to handle. So, oh, I don't know why I wrote x, I'm sorry. T equals, can anyone dictate? This is the quadratic formula. Negative b, what do I write? Exactly, 15. Negative b is 15. Plus or minus the square root of, just write 15 squared, minus 4 from the formula, 8, which is a. I should write times negative 3. Instead, I'm going to replace this by positive, so I don't have a lot of parentheses in there. Over 2 times a, which is 16. And see, now I need the calculator because I want to show you how to put this in the calculator. And this thing is frozen. Oh, maybe not. Anyway, maybe I can get out of it. Okay, I was able to get out of it. That's good. Oh, look at the graph. Finally. Okay, so the x-intercept, the other x-intercept, the y-intercept, and negative 1 comma 8. Okay, so good. So in parentheses, before we do this, I want to remind you that the graphing calculator doesn't know what you want to do. So you have to tell the graphing calculator that you need parentheses, and you will put parentheses around the numerator, and you will also put parentheses inside so it knows where to end the radical. Now if I had here 16 plus blah blah blah, I would have done the same thing with the denominator. But it's only one term, so we can get away without parentheses around 16. So the left parenthesis at the top, left parenthesis, 15 plus the square root in parentheses. You already have that. It pops up for you with parentheses. It doesn't for me. 15 squared and then plus 4 times 8 times 3. Close the parenthesis. Make sure you come out of that. You don't have to. I do with the software here. Close the parenthesis and divide by 16. And now I click enter. So this is 2.0, blah, blah, blah. Now the other one, here's what I do. With the second key, I call the previous entry. Why? Because I'm lazy. I don't want to type it in again. And then now I just go back and overwrite plus into a minus to get the other solution. Do you have to do this? No. If you want to enter it again, and press enter. Okay, since a negative time is not possible, although this is algebraically it's correct, but the meaning of time cannot be negative 0.18. So then I'm going to say it hits the ground again approximately after 2.06 seconds. I'm going to ask you question C, which is not in the problem.
Yes.
Yes.
I have a question. Okay, so since on the test we're normally supposed to show our work and stuff, if we get down to where we've written the 15 plus or minus.
I'm fine if you put the answer.
Okay.
Unless I specify something else, but other than that, you're fine. It is true the problem was saying here, find the exact time. So let's also find the exact time. We know that just the positive solution. So let's do that too. So the exact time will be 15 plus or minus. Now I have to perform this with a calculator. So I have 15 squared and plus 32 I multiplied times 3. Right? So that is 321. So the square root of 321 divided by 16. Now I have to try to see whether I can take some integers out of perfect squares from 321. So 321 is not an even number, so I will not start with it's not divisible by 2. So 3 plus 2 plus 1, this is a number that is divisible by 3, so I know the number itself will be divisible by 3. So then I have 107, right? Good. So is 107, is it divisible by anything? No. Okay, and this is the exact, but I will say only t equals 15 plus the square root of 321 divided by 16. Any questions? That's the exact. And this is the approximation of that. I want to add question C here. Find the maximum height reached by the head. Good. How do I go about doing that? I'm asking myself, what type of function is it? What functions are we studying now? Quadratic. Good. Does it have a maximum or a minimum? It better have the maximum because he cannot throw his hat in the ground. It better have a maximum, right? Because he cannot do this. He does this. The leading coefficient tells us whether the function is a maximum or a minimum, right? Good. Now what? How do I find the maximum? What point will give us the maximum for a quadratic function? Exactly. So I have to find the vertex. Good. How do I find the vertex in this particular form? Because I don't have that completed square form in which I can identify the vertex in a blink. So how do I find it? It's how we did it last time. How did we do it last time? B over 2a, yes. It's the x-coordinate of the vertex. It comes from the quadratic formula. So here it is. Here's our negative in front of the formula, of the ratio. And then b, which is 30. And then 2 times a, which is negative 32. It's time, so it has to be positive. So of course minus minus will change into plus. So the x-coordinate of the vertex equals 30 divided by 32. I will simplify by 6, right? By 2, and it's 15, and by 2 is 16. Okay, very good. So now, whatever this is, it's in seconds. But now how do I find the maximum? Exactly. How do I find the y-coordinate which will give us the maximum? If I have x. Yes. So I have d of 15 over 16. So let's go back to the graphing calculator. In y equals, clear what you have. And let's put in this new function we have. It was negative 16x squared. We don't have t, so we have to use negative 16x squared plus 30x and then plus 6. Here's what I do next. I go to second and table set. Make sure that your independent variable, it probably is, but mine is not. The independent variable is in the ask mode. So scroll down to and go to the right and press enter. And make sure that the independent variable only is in the ask mode. Do we have that? Good. So now we go to second and table. The table is the last button on the right under the viewing window. What do we want to plug in? Exactly. I don't care to calculate that even. So what is the maximum height reached by the hat? .063 measurement unit. Exactly. And since we have the answer in there, I'm going to say in approximately 0.94 seconds. So here's a scenario one more time. He or she takes his or her hat at time 0. Does this. After 0.94 seconds, the hat reaches the maximum. And from the beginning, when he does this, it hits the ground again after. Exactly. Because we understand the function, now it's very easy to picture what's happening. And this is an application of the quadratic function. Okay, moving on. Say it again.
Can we do something?
Yes, absolutely. Let's study the sign on. Can I make one up?
Sure. Yeah.
37, but it's a variation. I'm changing something in there. And I'm going to put an X in front. How many factors does this inequality have? How many? 4. Excellent. 1, 2, 3, 4. It's already factored. I can go ahead and use the chart. The first row in the chart must consist of the variable, the values of the variable. Thank you. Same you to you. Okay, that's from negative infinity to infinity. That's how they say it in Europe. You cannot just say, okay, thank you. You have to say, yes, Thank you. Same to you. Okay, here's the first factor is right here. Here's the second factor. Here's the third. Here's the fourth. And of course, I always run out of room. I'm just going to say product. And you know it's the whole thing. But I don't have enough room to put all those 4 factors in there. Now I need the x-intercept or the zeros for each and every one of them. So for this one, what would be the 0? For this one, what would be the 0? X equals... Very good. What will be the 0 for this one? And what will be the 0 for this one? Now I need them up here in ascending order. So don't put them in before you establish what they are, and then arrange them in ascending order. Now I have to identify the zeros for each of one of them and put the 0 under that number. So where do I put the 0 for x?
Yeah.
Where do I put the 0 for negative x plus 5? For x minus 6. And finally for x plus 3. Good. 3 of them have a positive slope. If you wanted to graph them, you would graph them like this. But one of them has a negative slope, and if you wanted to graph them, you'll have to graph it like this. Based on that, you can establish the sign. Or you can say, I don't want to think about graphs, I want to plug in numbers. That's another way. Between negative infinity and its 0, because it looks like this, it has to be negative. So it will be negative, and then absolutely positive, no question. This one, if you plug in a number between negative infinity and its 0, like negative 3, for example, negative 3 with minus in front will be 3 plus 5. So that's why this one has a different sequence of signs. But all the others with the positive leading coefficient will have the same sequence with negative and positive. Or you plug in a number. Is that clear? One time one student asked me how many pluses I put. It doesn't matter. You don't have to put pluses or minus. You can write negative if that's what you want. You can write positive. Do whatever you want. Any variation of this chart is fine. Whatever you want, as long as you understand what you're doing. So that now I see I have 1, 2, 3, 4, 5 subintervals. I only count the negatives. I have 3 negatives. When I multiply 3 negatives, I always get... Oh, I'm sorry, I forgot something. The product must be 0. We can continue before we do that. The product will be 0 when any of those factors is 0. So, as you said, negative. Now I'm here. I count the negatives. I see 2 negatives in the second subinterval. What is the sign? In the next subinterval, I only count a negative. What is the sign? In the next subinterval, I count 2 negatives. What is the sign? And in the last one, I count 1 negative. Only now, when I finished filling up the chart, only now I look at this sign or symbol. What sign is less than or equal to 0? And I choose that sign. Negative. Is the product ever negative? Yes, of course. It's negative here, it's negative here, and it's negative here. When? When x is here, when x is here, and when x is here. So then the solution is x is in the interval. Correct? Yes. Hold on for a second, because the inequality symbol has the equal symbol. I will close at -3. A bracket, in other words. If I did not have the equal symbol, I would have left it as a parenthesis. at -3. Union what?
0 to 5.
Both with,
Bracket.
and union again.
Bracket 6 to infinity.
That's it. Any questions? Okay. Let's look at another equation, like x cubed equals 27. How many solutions will this equation have?
3.
Exactly, because the polynomial has degree 3. I have to move 27 to the other side. So I make myself a note, 3 solutions. And then I will try to factor. It's a binomial. It's in descending order. Yes. Negative leading coefficient, no. Special product. I always hope for a special product. There are 4 special products in binomials. 2 with minus and 2 with plus. So I'm only thinking of those with minus. There are 2 with minus. Either the difference of squares or the difference of cubes. So now I have to identify whether x cubed is a perfect cube or a perfect square. It's a perfect cube. Once you say the difference of cubes, then you will give me a binomial times a trinomial. What is the binomial? What do I cube to get x cubed? What is the sequence of signs? If this is minus, what do I have here? And in the middle? Good. What do I cube to get 27? Careful. Good. And now this should be an easy pattern to remember. First one squared, the last one squared, and the middle one is the product. So what do I have in parentheses?
X squared
Yes?
minus,
It has to be plus.
plus.
Yes? That's why we put the sequence of signs first, so we don't mess up the signs. It does not have that 2, just 3x plus squared. Yes, because 3 times 3 will not be 27. So we need a 9. Good. What if you have doubts about this? How will you check that you are correct or not? Multiply, right? When you multiply x by these 3 terms and -3 by these 3 terms, what should you get at the end?
X cubed minus 27.
Of course. Of course. You will check immediately. Correct. So then I have from here 2 options. The option for the first one is that x equals good, but for the other one I have x squared plus 3x plus 9 equals 0. Not even try to factor this. It's not factorable. But I do have a method to solve this. What is that method? Yes. So let's apply the quadratic formula. So x equals -3, yes, plus or minus,
Square root of 3 squared.
which is 9, minus 4 times 1 times 9 over 2. Good. Like I did before with a similar situation, I recommend factor out 9 inside. It will be easier to figure out what you need to do than getting up a big number to work with and go back to factoring it. I realize that 9 and 9 are common to these 2 terms. So what do you have left in parentheses? That's very important. I have to have 2 terms. Because I have 2 terms here, I have to have 2 terms here. 9 times what is 9? Minus 4 divided by 2. So then I have x equals negative 3 plus or minus. I'm allowed to take the square root of 9, which is 3. And what do I have in parentheses? 1 minus 4 is? Yes, that's very important. Good, over 2. But what does the square root of negative 3 mean from chapter 10? Yes, but I have to write what it is. Exactly. Yes, 3i, the square root of 3 divided by 2. We don't like to put anything after the square root. Perfect. Let's look at problem 55. Any questions on this? And we found 3 solutions as expected. We found a real solution, and it happened that we found 2 imaginary solutions. That's always the case with the difference of cubes or the sum of cubes with degree 3. This will always have imaginary solutions. Always. If it's degree 3, if it's a higher degree, I don't know. I have to look at it. But if it's degree 3, this one squared quadratic expression will always have imaginary solutions from the difference or sum of cubes. Okay. Uh, 55 on page 709. Find 2 numbers whose product is as large as possible. Product, maximum. When I'm told as large as possible, maximum product. Given that their sum is 420. Sum is 420. So I'm asked to find 2 numbers whose sum is 420, but they happen to have, with the given restrictions, their sum is 420. This is given to us. That will have the maximum possible product. So where do I start? First of all, I have to think of 2 numbers, but I can't say 200 and 220 because the sum is 4. No, I can't say only x and y. I'm thinking of 2 numbers, x comma y. Their sum is 420. What would you write to express that? That the sum of the 2 numbers that you use, or we want to use, the letters, the variables we want to use, is 420. How do I write that? The sum. The sum is 420. Good. Now I would like you to express the product of these 2 numbers. The sum is given to us to be 420. Now I would like to think in terms of the product. How will you write the product of these 2 numbers? We don't have them, but we denoted them by x and y. Very good. Good. My next question. When we talk about the maximum, what kind of function do we have in mind? If it's a product or if it's whatever. But when we talk about, so far in the course, when we talk about maximum, what function did we have in mind? Not linear. Exactly. So I want somehow, that's my hope, that I can present the product as a quadratic function. That's my hope. If I can present this product as a quadratic function, then from there, what do I determine to find its maximum? There's only one point that gives us the maximum of a quadratic function. It's called... Exactly. But I don't have this. I don't have a quadratic function that is the product yet. Okay. But look at this. This is given to us. I can solve it for one of the variables and plug it in here. And then I will get the product to be a quadratic function. Let's solve this equation for any variable you want. Okay. We decided to solve it for x. Then how much is x? Exactly. Now let's plug this in here. How would you plug it in? And look at this. Is this quadratic? Does it have a maximum? How do I know? The negative leading coefficient. It has to have a maximum. So once I have the function, I look at it and I say, yeah, it has a maximum. How do I determine the maximum? I have to use the information that I'm given, right? I'm given this for a purpose. I'm told that the sum is 420. So I can solve for one or the other. It doesn't matter which one. So then, how do I find the vertex? B. Remember, that's the reason why I already presented in descending order, because if I present it the other way around, who knows what I come up with. Always remember, factor, simplify, descending order, those are crucial. So 420 for B, 2 times A. So the answer is 420 divided by 2, so this is 210. So this is 210. So the y variable, y number, not the y variable, I don't need to confuse, this is y. We denoted one number by y. Doesn't mean that it's this y. We just denoted by y. Okay? So y variable or y number is 210. If y is 210, can anyone identify the other number? Exactly. 420 minus 210 is 210. Now, I would like to find the max product. Either you go back with 210 in here, or you know where we came from. This is where we came from. X times y. Or you plug in, as we did with the graphs, you plug in 210 in here, and you'll get the same answer. It doesn't matter. So we can do this in both ways. So I can do 210 squared, or I can plug it in the function as negative, no parentheses, 210 squared plus 420 times 210. If I want to plug it back in the function as we did, it has to be the same number. Because our function, which function? This one. This function came from here. So once I have x and y, this product must equal this. That's how we got this. By using x times y and replacing x by this. Okay, let's look at another word problem. 54. Any questions on this one? Oh, I would like to write the final conclusion. So, the maximum product, oh, I didn't even put it in, 44, 100. The maximum product of two numbers that add up to 420 is 44,100. The numbers are 210 and 210 respectively. I have to write this conclusion. So, the maximum product of two numbers that add up to 420, that's the condition that we were given from the beginning. The maximum product is 44,100. The numbers in our problem are 210 and 210 respectively. Okay, let's look at the next one. Uh, 54 on page 709. The function h of t equals negative 16t squared plus 120t plus 300 gives the height in feet of a projectile fired from the top of a building after t seconds. So we're here, this is the top of the building, and we are firing the projectile like this. What type of function is this? Is it clear? Negative leading coefficient? It has to look like this. I don't know the x and y intercepts, I don't care right now, but I know that it has to do this because the leading coefficient is negative. Very good. When will the object reach a height of 350 feet? So this is 300. And let's say this is 350 feet. So first of all, the projectile will reach the height of 350 on its way up to the maximum, but also on its way down to the ground. So I should get two different time, right? T1 from here, here, and then T2 from here, here. Okay, good. How do I do that? Exactly. Exactly. I refuse to solve a quadratic equation with a negative leading coefficient, so I will move everything to the left. So 16t squared minus 120t, and 350 minus 300 is plus 50 equals 0. And of course, I will try to simplify it first. And I can only divide by, indeed. So 8t squared minus 60t plus 25 equals 0. My only chance is the quadratic formula. Negative b, plus or minus the square root of. You cannot say negative. This has to be 60 squared. Even if b is negative, because we have to square it, it will always be positive. Minus 4 times 8 times 25 over 2 times 8, which is 16. Let's put all this in the graphing calculator. And remember, we have to get two different times, right? Because it crosses the line of 350 unless that is a maximum. If it is the maximum, then it will only touch it once, because that's the maximum. But if that's not the maximum, and then the projectile will cross 350, will reach a maximum, and come back, cross 350 again, and hit the ground. Okay, so don't forget about parentheses around the top. Parentheses, 60 plus the square root. In parentheses inside, I have to put them, maybe not, but I'm old-fashioned. So minus 4 times 32 times 25. Close the parenthesis, close the outside, and then divide by 16. Again, with second an entry, and replace the positive by negative in front of the square root, of course. And press enter. And here it is. So, one more time. The time between this point and this point, it's going to be our T1, which is 0.44 seconds. So this is between 0.1 and 0.2. But the time between 0.1 and 0.3 will be how much? I'm going to call it T2. How much?
7.06.
Exactly. Next question. Explain why part A has two answers. On its way up and when it's way down. I want to add another question here. Part C. Find the maximum height. How do I find the maximum height? First of all, I have to ask myself, what kind of function is this? Good. Does it have a maximum? Yes. We know that. Good. How do I find the maximum? Good.
Negative B over 2A.
Negative. B.
60.
Careful.
Get rid of 120.
Very good. Over.
Negative 32.
Very good. Excellent. So it has to be positive 120 and 32 by 6. I don't know why I'm dividing 32 by 6. I have no idea. This is the second time I'm doing it. So by, by 4, and I get 30 over 8. Right? So what is that? How much?
15.
Right. Okay. Perfect. I just need the maximum. How do I find the maximum height?
Plug that in as the
Yes.
A60 or S60.
Very good. So let's go to the graphing calculator. I can divide that 120 by 32. That's 3.75, which is fine. So in y equals, clear the function you had, negative 16 x squared, and then plus 120x, I'm so sorry, plus 300. And then we go to second and table, and we plug in 3.75. So we plug in 3.75, and we get 525. So what is the maximum height of the projectile? 525 feet. So it's up here. 525 feet. This height is 525. And when does it reach it? Between 0.1 and 0.4, the time is 3.75 seconds. So 3.75 seconds from the launching of the projectile, it reaches the maximum and then eventually hits the ground. And we still have a minute or two. I would like now to find when does it hit the ground. When does the projectile hit the ground? How do I determine that? When it hits the ground? Exactly. When anything hits the ground, the height must be 0. Very good. So negative 16t squared plus 120t plus 300 equals 0. I will definitely divide both sides by negative 4. So let's see. So I have 4t squared minus 30t and minus, that's 75, right? 300 divided by 2 is 150, and divided again by 2 is 75. Good. What do I use now?
Quadratic.
Yes. Yes. So then t equals negative b plus or minus b squared minus 4ac. 4 times 4 is 16 times 75. I'm changing the sign because c is negative. Over 2 times a, which is 8. Again, back to the graphing calculator. Don't forget to put parentheses around the top. Parentheses 30 plus the square root. In parentheses again, 30 squared, and then plus 16 times 75. Close the parenthesis for the square root, close the parenthesis outside, and divide everything by 8. Yes, there is another solution with minus. So I have to go back and overwrite plus in front of the square root. Change it to minus. Right. One of them is unacceptable because time cannot be negative. So the time needed for the projectile to hit the ground is
9.48 seconds.
exactly 9.48 approximately seconds. Very good. I recommend try all these problems except the ratios. You cannot do the ratios, right? You cannot do 23, for example. You cannot do 69 because that's part of 36, because those are part of chapter 7. And we haven't gotten to that yet. That's our next step. Any questions?